of the things I think is really cool is that this isn't one company out there driving this. This is a global community of researchers and very talented developers who are building some really cool stuff. So we're just part of that whole tapestry and doing our bit. But anything we can do to make it easier for developers to work with this stuff, I'm happy.
You have just heard Will Eastcott, the CEO of PlayCanvas, one of the most popular open source 3D engines for the web. Before founding PlayCanvas, Will worked at major game studios like EA, Sony, Activision, contributing on games like GTA, Call of Duty, and Max Payne. Today, PlayCanvas' mission is to make web app development more accessible and collaborative. In these episodes, Will shares invaluable insight and the game-changing tool he has built to help developers through their journey. We will discuss the current state of 3D on the web for gaming and beyond.
If you kind of rewind and look at some of the very early pitches, I was describing PlayCanvas as being really built for indie game developers. We haven't seen web gaming explode over the last, say, 12 years. There's a number of reasons. One of the main ones is all around monetization. There are lots of other verticals where you can apply interactive real-time 3D on the web.
Practical tips to help developers choose their web engine and optimize their experiences on the web.
After 6 seconds, 40% of your audience will bounce, right? So obviously getting that first time user interaction time way down is absolutely critical. Optimization is a very important thing. And the one thing I would always advise any content creator to do is think about it. Reducing the number of vertices, it will make a difference. But actually, you want to spend more of your time concerned about how you're on the texture side of things. I mentioned that's probably the biggest win. It's really smart. It's like an order of magnitude less memory that's taken up by the texture data. Is an absolute no-brainer.
And how you can clean and edit your Gaussian splatting directly on the browser.
And Splat allows you to import the PLY file that comes out of the InReader tools, or indeed Polycam or Luma. It's basically your one-stop shop for cleaning up, editing, and optimizing your splats. The reason why Splat is considered the de facto application for working with splats is because it's not tied to any particular engine. You can happily use it with Unreal or Unity or indeed PlayCanvas, and it's open source. It runs in the browser, so it's super accessible.
But before we get into it, I wanted to thank our sponsor Meshy, who made this episode possible. Meshy is a real powerhouse for generating 3D assets with AI. You can start with a simple text or image prompt and get high-quality stylized 3D models in just a minute. One feature I personally love is the ability to create stylized texture for any mesh, with or without UV. And since the release, Meshy's teams keep pushing amazing updates like texture inpainting, ultra-realistic sculpture, and the ability to rig and animate your character. To try it out, go to meshy.ai and start the 7 days trial to access all these incredible features. And now it's time to roll the title and welcome Will under the spotlight. Will, it is a real pleasure to have you here.
Thanks, Gabriele. It's a pleasure to be here.
So I want to start with a bit of what you're very much known for, that is being PlayCanvas, right? And sometimes people might say that web gaming hasn't really taken off as some were hoping for. What do you think is the missing piece that could lead to, let's say, a broader adoption, for example?
Yeah, it's a great question. I mean, it's actually kind of interesting that PlayCanvas was originally intended for game developers, almost exclusively. So if you kind of rewind and look at some of the very early pitches I did, to investors and at conferences and stuff, I was describing PlayCanvas as being really built for indie game developers. But as time's gone on, it's become pretty clear to me that there are lots of other verticals where you can apply interactive real-time 3D on the web. You see brands wanting to do sort of more like advertising-based experiences, and you get like product visualizers and 3D configurators, and there's a ton of other different use cases as well. But I'd still say gaming is still in my DNA. It's kind of where I spent most of my time building my career. So I still care really, really deeply about gaming. And don't get me wrong, there's still a lot of game developers that use PlayCanvas, but we now serve a much wider audience. But as to like why maybe we haven't seen web gaming explode over the last, say, 12 years while we've had WebGL integrated into browsers. Um, there's a number of reasons. I mean, I think one of the main ones is all around monetization. It's very difficult to effectively monetize a game on the web, and you know you've got a few options. Basically, you can kind of go down the sort of ad route where you either serve interstitials, videos, that sort of thing, or you have some kind of sort of in-app payments type solution where you can sell digital items in your game, or you can sell some like a subscription or some type of access to your game. But doing that on the web is clearly a lot more difficult than it is on a than when say an app developer would be using the sort of integrated mobile OS to take payments, where it's a lot easier. It's just like, hey, I'm gonna double click on the side of my iPhone and make a payment. It's a lot harder on the web. So I think that's the number one drag on the sort of progress for web gaming, because it's just a lot harder to get monetization to work and work well.
So you mentioned a very good point, right? Being that the use cases for PlayCanvas and for in general for the web expanded beyond gaming, right? And I want to go there because I'm curious also to know how PlayCanvas sees currently their infrastructure be used at the moment, right? But before getting into that, I'm most curious. So what would be then right now the compelling reason for a studio to start developing for the web? I mean, when is you would say, yes, invest in it, it does make sense for you? And it could be a business thing. It could be like an exposure thing. It could be many different, I imagine. So what would you say could be the reason?
In terms of being a game studio, do you mean?
In this case, yes.
Yeah. So, yeah. Well, I mean, I think there's lots of benefits to becoming like a hardcore web developer. And I think, I can probably run through some of those. So for example, the web is, for all intents and purposes, pretty uncontrolled. You have ultimate freedom in how and where you publish your content and the timing around that. There's no kind of restrictions or regulations about, the content you want to publish. So I personally am a big fan of the incredible freedom that you have around publishing your content. On top of that, I think the web has an astonishingly large audience ready to go from day one. So you can publish any content to a URL, and you have billions of devices around the globe that can access that content immediately. So if you develop the necessary skills to be able to spread your content to that audience effectively, then it can be incredibly powerful. Now, that's a very difficult thing to do. And, like becoming an expert in SEO and being able to...
there is a whole marketing world that then needs to complement the development skills, of course.
Yeah, exactly. And I think a lot of people who want to get started making a web game, they don't initially spend a lot of time thinking about some of these skills. And but really, I mean, like it's critical for the success of your project. And this is why it's quite interesting to see companies like Pocky, for example, who are now very successful. They're a successful web game publisher. And so they have their own portal, and they work with third-party developers to help them publish their games and then give them an audience. And they have all of these tools built around their platform that allows them to, like do a closed beta test of a game and get analytics back, and before doing like a full rollout. And so, I mean, I'd like to see more companies.
Can you say again the name, Will, just so that people can, if in case they missed it?
Yeah, they're called Pocky. It's Poki.
Okay, perfect. So then I think interesting for people that might be willing to go into it, and it's not just about the development, but then the whole packaging and the extra layer of analytics that you mentioned, right? That you could do.
Yeah, exactly. Yeah.
So when we look beyond gaming, right? You mentioned that there are other things like, for example, configurators, ads, or more, right? So what else can you do with web, and what else PlayCanvas works extremely well for?
PlayCanvas is what I call like a genre agnostic engine. If you want to do anything that's interactive 3D, then PlayCanvas should be able to enable you to build that content. So, I guess we started from that point of trying to build something that's relevant to game developers. But over the years, we've managed to turn it into something that's very, very general purpose. So sure, we get a lot of content creators who are making these really awesome product visualizers and 3D configurators, especially in verticals like automotive, for example. So you can see some really high quality, very performant 3D rendering in some of those applications. And you tend to find that brands, when they want to publish content to the web, they really care about their products being represented very faithfully. They want them to look like absolutely perfect. So this is why, it's forced us as a team to really be at the bleeding edge of graphics techniques and enable those to work in the web, so that these developers can capitalize on that. Those are actually the kind of developers that I love working with, because I love to work at the bleeding edge of graphics techniques, and the graphics engine in PlayCanvas is incredibly capable. And of course, you mentioned earlier 3D Gaussian splatting. This is just like a whole new level of photorealism. So as soon as that became a thing about a year ago, like the PlayCanvas team was all over that. Yeah.
Right. So that explains why at some point I saw that popping everywhere on your feed. And I was like, so it's that love for the graphical, realistic representation of object graphics. Other than maybe what could be, for example, gameplay. Am I correct? Is that something that you would prioritize in terms of passions, at least?
Yeah. Like I said, games is really in my DNA. I used to work on console games.
Okay.
I've been incredibly lucky to be able to work with the teams working on these games like Grand Theft Auto and Call of Duty and stuff like that. That's super fun. And when it comes to a typical like 3D configurator or product visualizer, the kind of the sort of user interactions that you get in those applications are quite basic, right? You maybe want to like zoom into an object, or you want to spin an object around, or modify some colors or components on that item. But actually, like, the reason why I think games is catering to game developers is interesting to me, because they really do push things in terms of behavior, gameplay, logic. And so they need some very powerful tools to be able to, make game objects behave in an interesting way. So whether that's like a vehicle racing around the track, or a character like jumping over a wall or whatever, like those kinds of things go way beyond what a typical brand would want to do. So this is why PlayCanvas also supports some pretty advanced subsystems covering things like animation and physics and things like that.
So the underlying platform on which these experiences, either being ads, configurator, games, 3D visualizer, are built is fundamental. And right now, there are indeed, for someone that wants to step into this, there are different choices, right? There is Wonderland Engine, there is Needle, there is A-Frame, and then, of course, there is PlayCanvas. And probably many more that I'm forgetting right now. The question is, how can you help people decide what is the best platform based on their need?
Yeah, well, the thing about 3D content developers is that they come with different levels of expertise and experience. And every engine or framework or solution out there for building content tends to cater to like a different profile in terms of skills and stuff. So, so PlayCanvas, when we started building it, we thought it was very important to provide a visual interface to build your content. So there's an editor where you can drag and drop assets and construct a scene visually. And yes, there's also like a programming interface where you can program logic and behavior. But a lot of the work that you do in the editor is kind of very visual. And so, yeah, like if there was a developer who maybe preferred to work in that kind of environment, that would be a good fit. But you have other frameworks that are available. I mean, if you look at, for example, Babylon.js or Three.js, those are JavaScript frameworks where you would typically open up Visual Studio Code and you'd write your application in code. So I'd say PlayCanvas it probably is a bit more geared towards the Unity demographic, whereas there are other solutions out there that are a bit more focused on programmers. But like, yeah, I mean, so I guess from my point of view, when it comes to building technology, for me, I try to make the development process very efficient and accessible. And I think you can do that better through visual tooling. And now I'd say like PlayCanvas itself has actually evolved into, it's no longer kind of this monolithic editor. You've now got like a platform. It's like a graphics creation platform that provides you with a set of tools that can work independently, and you can mix and match them with other tools. So we have a GLTF viewer. We have a Super Splat, Gaussian Splat editor. We have our scene editor. We have a texture viewer. We also have like, we haven't released it yet, but it's like a node-based shader graph editor. And so, like, I guess while it's valuable to have like a really awesome runtime with a very advanced graphics engine, I think unless you provide powerful tools on top of that, your developers aren't going to have a very easy development experience. I guess that's my philosophy.
So you mentioned as a parameter to pick your weapon, so to say, is the experience, the level of experience of the developer. Yeah. I imagine, and here is a guess, there could be also another element being the kind of content that you're building. So, for example, imagine there is a social game, or there is a 3D visualizer, or there is a WebXR experience, right? Because, of course, we also know that the web is extremely powerful for that. Would there be also some recommendation that you could give in this case based on the type of content people are building?
Yeah, I mean, I would always recommend that any developer do evaluations of products that might be a good fit for them and their skills and the projects on which they want to work on. So, obviously, I'm always going to be biased and an advocate towards people using PlayCanvas. And it is a general purpose platform. So whether you want to make any of those kinds of applications, PlayCanvas should be perfect for doing that. But like I said, it really comes down to your specific needs and your specific experience as to which platform, which tool resonates with you the most. Because there are so many variables, right? It's not just about the technology. It's also about, say, the community or the developer resources. Like, you need to go and take a look at all of those and say, I feel at home in this community. I feel like I belong here. Or these developer resources are easy to understand, and I'm going to be able to learn this very quickly. So there's a whole bunch of, there's this big combinatorial I guess assessment you're going to have to go through to like check out all these things and then come to a decision. But the great thing is today is that it's not like there's some monopoly out there where there's just one solution and it's kind of the only thing in town. There's lots and lots of choice out there, And so, yeah, I would just encourage developers, do your homework and go and explore.
So one of the things that scares sometimes people away from developing for the web is the level of optimization that is needed in order to bring whatever is their 3D model assets, interactivity, and so on the web, right? And I believe you do have a lot of experience when it comes to optimizing those assets. And I was curious to know if there were any practical, let's say, tips or guidelines that you could give when, for example, looking at textures or looking at meshes. Can you share something with us?
Oh yes, this is a topic that's very dear to my heart. So the web is unlike any other platform, right? Like it's interesting to look at, say, a platform like Unity, and they've elected to support the web through essentially compiling their runtime to WebAssembly, and they're kind of just treating it like another platform, like a console or like a mobile device. But the web is unique, and it should be treated very differently from any other like hardware device. Um, so it has its own characteristics. For example, um, everything you load is through the browser, and that browser will be streaming that content. And there's an expectation that's maybe different with web users about the speed with which that content loads. I think there are statistics that say after 6 seconds, 40% of your audience will bounce, right? So obviously, incrementally streaming an application and getting that first time user interaction time way down is absolutely critical. So this is why PlayCanvas as a browser um, engine um, is being optimized very heavily to allow you to asynchronously stream assets that are compressed, that can be parsed and loaded insanely quickly, so that that very first menu, that very first interaction that the user makes happens within like a second or two. Load times, yeah, that's one big thing. And I mentioned compression. So we've seen some very interesting compression standards being released over the last, say, 5 or so years. Things like Draco compression for mesh data, vertex data. You have basis compression from Binomial, which compresses texture data with very few visual artifacts. So PlayCanvas leans very heavily on these compression algorithms to enable you to deliver content that looks great but streams very quickly. And then also on the other side of the other kind of like elements of performance or optimization is around sort of your runtime performance. So um, most people, when they work on optimization, they're just thinking about, oh, I just have to hit 60 frames a second and my job is done. Well, we live in a mobile first world today where actually you don't just want to hit 60, you want to, the goal is really to put as little load as possible onto the CPU and GPU. And the reason is because you want to conserve battery. So we spend a huge amount of time optimizing our shader and CPU side code to enable you to enable your device to run cool and conserve the battery for as long as possible. So a lot of that optimization we've done in our code, but there's still a bunch of guidelines or just I guess best practices that you'd want to follow to ensure that your game runs quickly. And we document all those on our website. If you just Googled like PlayCanvas optimization, we have tons of documentation on all that stuff. But yeah, I mean, optimization is a very important thing. And the one thing I would always advise any content creator to do is think about it from the beginning. Don't wait until the end, because optimization and performance will probably dictate the architecture of your application. So think about it from step one, and that will speak to the rest of your development.
I wanted to have a quick break to remind you that if you like this conversation, you should check all past episodes at xraispotlight.com. Also, if you don't want to miss anything, remember to subscribe to the XR AI Spotlight newsletter, and you will immediately get an updated list with over 200 mixed reality apps you can filter from various fields, weekly in-depth interviews, and one product spotlight personally tested by me right in your mailbox every week. And now, let's get back to the show.
So I'm pretty sure that whoever is interested is going to run now to the PlayCanvas website optimization and check for those. I am curious if you have maybe one of the, let's say, one for meshes, one for texture. I'm hinting back at those because I know that those are like, I have this 1 million polygon mesh. What can I do to get it in VR as well, right? Because that's a very similar story. Same thing for textures. So is there a quick win that you could share? Hey, guys, do at least this with texture, do at least this with meshes that comes to mind that usually people forget or neglect?
Yeah. So the interesting thing about meshes is that you kind of rarely see GPUs being limited through transforming vertex data. Because when you run a shader, you first of all run a vertex shader and then a fragment shader, which fills pixels. So say if you have a triangle that has 3 vertices, you will transform those 3 vertices on the GPU, and then you'll fill every pixel of the triangle on the screen. And the cost of transforming the vertices tends to be not the bottleneck. It tends to be filling the pixels. That tends to be where the GPU spends most of its time. So reducing the number of vertices, it will make a difference. But actually, you want to spend more of your time concerned about how you're filling pixels. So looking at how your shadows are configured, how your lighting is configured. Do you have any other things enabled, like full screen effects that do things like bloom or motion blur or anything else like that, anti-aliasing and so on? So all of that side of things, where the GPU is filling pixels, that's where you want to spend 90% of your time concerned with. So that's what I'd say about sort of the mesh side of things. On the texture side of things, I mentioned the basis text compression. That's probably the biggest win. It's really smart. What they've done is they allow you to take an image, like let's say you have like a 4K by 4K JPEG or something. Now, if you downloaded that onto your device, the browser will actually expand that out into uncompressed pixel data. So whereas the original JPEG may be 100K, once it's expanded within the browser to main memory, it could be hundreds of megabytes. So what you need to do is compress it with basis, and the format that compressed data takes maps extremely closely to the natively supported compressed formats supported by the GPU. So the basis transcoder, what it does is it downloads the basis texture. It says, well, what formats are supported by the GPU? Okay, it's ASTC. So I'm just going to transcode the basis texture to the ASTC, and then I'm going to upload it. And you can find that you can, it's like an order of magnitude less memory that's taken up by the texture data. So leveraging basis is an absolute no-brainer.
Awesome. I think that people now know where to go. Thanks, and apologies for keep digging into it, but sometimes I really want people to get something straight away from the conversation. But go on the Canvas optimization section, because I'm pretty sure that there is more of this goodness if anybody here is interested. We were discussing about, of course, 3D, right? And Gaussian Splat is the new 3D in a way. You mentioned you're passionate about it. Can you maybe just, for whoever doesn't know, in a couple sentences, what Gaussian splats are, but then what super splat is?
Yeah. Okay. Yeah. Let's talk about this. So Gaussian splatting is a way of digitizing reality. So you can take some photogrammetry. So you can get a camera, smartphone, take some photos, or indeed a video, and you can run that photogrammetry data through some tools that will generate a PLY file. And the PLY file contains these Gaussian splats. Now, what are Gaussian splats? They are they're little volumetric particles, and as the camera moves around the scene, these blobs can change shape and color and opacity, right? So if you have millions of these little blobs, and they're all uh, used together to represent an object like a car or a person. As you move around the object, you can't see the individual blobs, but as you move around, you'll see that they change shape um, to maybe reflect things like changes in lighting as you move around. So if you have an object that's shiny, some of those blobs will change from like black to white to black to represent light passing over that object. And yeah, so you can render things incredibly photorealistically using splats. And actually, the tools that are used to go from the photogrammetry to the Gaussian splats, that works by analyzing all of the images that were taken and the original camera positions are deduced. And once we have the camera positions, we can then do this iterative pass when we go through all of the camera, all of the images for each camera, and we fit these individual particles to make the object look correct from each camera position. And so that's kind of how it works. So that's called the training phase, and you can run it for like say 100,000 iterations, and at the end of all those iterations, you'll have each blob correctly figured.
When we go into what you're gonna do with those splats, I have a question. Which is your favorite way for capturing these splats right now? Do you use an app? Do you use your own phone and another third party? How does that work for you right now?
I think if you're new to Splats, an easy way to start is by using something like the Polycam app you can download onto your phone. There's also Luma AI, and these make it super easy. You just start the app, you do a capture around an object, and it has some guides that tell you where to place the camera and makes it very easy. But if you want to get pretty advanced at this stuff and achieve the highest quality, you can get like a decent digital SLR camera and take photographs using that, maybe like 100 photographs, and then you run those images through some tools that were the source code was released last year. These tools were provided by INRIA, which is a French research institute, and they wrote the original paper on Gaussian splatting last summer. So yeah, you can just download these tools and run them on your PC. But again, to do that, you'd need a decent PC with a NVIDIA GPU. So yeah, there's a few. If you want to get better at this stuff, yeah, like you need the PC and you need to.
The stealing is endless, of course, close to endless. Then, so what's the workflow now? I have this PLY file. There are these blobs all over the place, likely.
Yeah.
This means also the background that somehow got captured in. For example, if it was a 3D object, right? What's next?
Yeah, well, actually, maybe I should just show you Super Splat. That's probably a good thing to do. So, if I just select the window. Okay, so can you see that?
Yes, go ahead.
Great. Okay, so I'm going to, let's see now. I'm going to just drop in, maybe if we drop in this, yeah. Okay, so here is a reasonably well-known, it was shared a few times online, but this is a room that somebody scanned. So this is basically what comes out of the tools. And if I kind of just zoom out a bit, you can see there's like lots of splats floating around, and you may want to clean up the scene and start deleting some of these sort of wayward splats. And so this tool that we've written, SuperSplat, allows you to import the PLY file that comes out of the InReader tools, or indeed Polycam or Luma, and then you can clean it up and you can do selections and delete stuff. But yeah, so once you've kind of you've done all of that, you can do things like, as well, you can kind of like transform your splat in 3D space, or indeed rotate it. You can also export your scene to compressed formats. So different engines support different splat formats. PlayCanvas has its own compressed format, which is this one here. And then there's a .splat format that's supported by some other engines. But this tool is basically, your one-stop shop for, cleaning up, editing, and optimizing your splats. I could grab another thing. What else? Let's see.
And while you do that, I want to also mention and emphasize that. So first of all, this, of course, is all running on the web. Let's not forget that, just for give context to people. And the other thing is, of course, that this seems so straightforward, but honestly, I don't know about any other way to easily edit and clean up a splat right now. Just I personally, I don't know you, Will, if there are other options, how easy it will be, but this is, to my knowledge, the only one I know.
Yeah, so you can do basic editing in like Blender and Unity and PostShot, but I think that the reason why SuperSplat is I guess considered the de facto application for working with splats is because it's not tied to any particular engine. You can happily use it with Unreal or Unity or indeed PlayCanvas. And it's open source. It runs in the browser, so it's super accessible. And to be honest with you as well, maybe I would say this, but it's really well engineered. There's a guy on my team called Donovan who's leading development on this application, and I love using it. It's beautifully designed. It looks fantastic. So yeah, I think that's probably why it's become so popular. It's just really nicely built.
Will, was there anything else you want to show us with this beautiful plush toy?
Well, I think the only other thing just to mention, I think this is a really nice example. It shows the kind of the strength of Gaussian splats for certain types of objects. So you can see it really, really does capture things like sort of furry, textured materials incredibly well. If you were going to get a 3D artist to go and build this, you would probably need also an extremely talented shader author to come up with some kind of fur shader. But Gaussian splatting just captures this so beautifully, so faithfully. So, there's certainly certain types of objects that the splatting works best with, but I think this is a really nice example.
Awesome. So then what? Right, because the other point is that there is a lot of interest, of course, around Gaussian splattings. Now we can capture them easily, we can edit them easily, but then you still have that splat that is not exactly a mesh, right? So What is the next step, and where do these 3D models end up being served, delivered?
Yeah. So we got to remember we're only a year into this exciting new world of Gaussian splatting, and a huge amount of research is underway right now to investigate topics like animation or relighting, because obviously the lighting is kind of baked into the object. There's lots of interesting things that are going to be possible in the future that we can't do today. But I think even now we have lots of interesting opportunities to use splatting, particularly in things like product visualization. And again, maybe not for everything. So while you can capture things like a car, the quality is going to be better for things like furniture or clothing. So maybe we're going to see more of that sort of thing to begin with. But as time progresses, we're going to see the quality get better. We're going to see other techniques being integrated into splatting, and so we're just at the beginning, and when it comes to supporting splatting in Splat, in the PlayCanvas editor, and in the engine, we're going to be tracking all of these developers, and this is one of the things I think is really cool is that this isn't one company out there driving this. This is a global community of researchers and very talented developers who are building some really cool stuff. So we're just part of that whole tapestry and doing our bit. But anything we can do to make it easier for developers to work with this stuff, I'm happy.
So that was I want to kind of last couple of questions about this intersection between what you guys are doing and XR, right? Because that is also like being 3D. That is one of the places where all this content is gonna live in. And PlayCanvas is, of course, part of Snap, who have recently announced the spectacles. So I'm curious, how do you see PlayCanvas, Splat, and what you have built and are building supporting that vision of digital content existing, living, and being interactive in our physical space?
Yeah, well, I think anybody who, say, follows me on X probably gets to see a lot of my personal ideas about where all this stuff is going, because I tend to do a lot of experimentation around some of these ideas and do it very publicly. A lot of the stuff I've been posting about recently is to do with, like room scale splat environments. And so I did some posts, I think a couple of weeks ago, where I took a very beautiful Gaussian splat gallery that was made by somebody on X, and I just threw that into PlayCanvas, and you can explore this WebXR app in Apple Vision Pro or Quest 3, say, and it's astonishing. It's like you're transported to some completely photorealistic world, and it's very convincing. And I think XR and Gaussian splatting, there's a really good overlap there. There's also some interesting applications when it comes to maybe building avatars out of Gaussian splats. And then, like I said, animation is something that is being worked on right now. But if we can come up with a solution where you can essentially capture yourself as an avatar and then stream that over the internet, you can have face-to-face conversations with people. And then when you throw devices like spectacles into the mix, where you have a very convenient form factor where you can instantly be transported to another location or be able to talk to a friend who's maybe the other side of the world. I mean, there's some very, very cool, exciting applications for this.
So, Will, I mean, thank you very much. I think that people have certainly learned a lot. And I mean, if you are now into Gaussian Splat, it is as easy indeed as you downloading Luma AI or Polycam on your phone, getting the PLY file and get it into Splat. And from there, you can just clean it up, and then you have something ready that, as Will mentioned, can go as an existing 3D model on any website, right? So absolutely, Will, thank you very much. Anything else you want to add?
No, that's probably everything. Yeah.
Perfect. Then, Will, thank you very, very much for being with us today.
Great, it was a lot of fun.
Thank you very much for listening in. If you like the show, please leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really means a lot to me, and it's a great support for the show. Till next time.